What happens when the smartest scientist doesn't have a face, a name, or even a soul? A former Google CEO just unleashed AI agents smarter than PhDs for free. So here's the real question: are humans still needed in science? In the quiet shadow of Silicon Valley, something unprecedented has emerged. Not another app, not another startup, but a new breed of intelligence. It's not human, it doesn't sleep, it doesn't brag, and it doesn't get tired after reading 400 research papers in one night. It's called Future House, a non-profit scientific initiative backed by Eric Schmidt, former CEO of Google, and it just introduced 4 AI agents that may very well redefine what it means to do science. These aren't your typical AI chatbots. They don't want to talk about lunch or generate haikus. They're built with a single, brutal focus: accelerate discovery. Named Crow, Falcon, Owl, and Phoenix. These agents specialize in hard science, processing research papers, analyzing gene data, synthesizing new molecules, and they're doing it at speeds that humiliate the human intellect. But here's the twist: these tools are public, free to use, no gated beta, no waiting list. Anyone from a Nobel Prize winner to a first-year biology student can log on and start wielding an AI assistant that, by some metrics, is already outperforming PhDs. The democratization of scientific superintelligence isn't coming, it's here. Each agent has a specific personality and role. One skims journals faster than a caffeine-fueled postdoc. Another proposes experimental designs with algorithmic precision. One detects overlooked gaps in literature, and one invents molecules from scratch. They're modular, they're chainable, and they're more transparent than most senior researchers you'll meet at a conference. So what does this mean? If the process of asking, researching, analyzing, and hypothesizing can be offloaded to machines, if scientific brilliance becomes as accessible as a website login, then where does that leave us? Not just as researchers, but as thinkers, as meaning makers. The launch of Future House is not just a technical milestone. It's a philosophical earthquake. We're no longer just building tools. We're creating minds that might one day outthink, outwork, and maybe even outreason us. The question is no longer whether AI can help scientists. It's whether scientists will still be the ones leading science. Science, in its rawest form, is just organized curiosity, but when curiosity gets compressed into silicon, it doesn't slow down for coffee breaks or self-doubt. It scales, and Future House has bottled that scale into 4 distinct agents, each one a digital archetype of scientific labor, engineered not to impress your boss, but to outperform entire departments. First, there's Crow, the rapid-fire generalist. Ask it a technical question, and it doesn't just generate a guess. It scans the latest open-access papers, evaluates citation strength, and delivers an answer with linked references. It doesn't summarize, it justifies, like a turbocharged research assistant that never forgets a DOI. Then comes Falcon, the deep reader. While Crow is your quick-hit sniper, Falcon is the marathon runner. It inhales entire libraries of full-text academic articles, including proprietary datasets like open targets, and distills them into long-form scientific reviews that feel like they were penned by a top-tier postdoc with zero ego and unlimited time. The kind of assistant every scientist dreams of and can now actually access. Next is Owl, the quiet observer with a forensic eye. Owl doesn't guess what's been done, it checks. If you're about to start an experiment that's already been tried and failed somewhere obscure, Owl finds it. It scrapes the archives, flags similar studies, and whispers, "Don't waste 6 months reinventing the pipette." It's the ultimate anti-redundancy tool in a world drowning in forgotten PDFs. And finally, there's Phoenix, the most experimental of the 4, and possibly the most dangerous. Phoenix is not a reader, it's a creator. It designs molecules, simulates chemical reactions, checks patent status, evaluates solubility, and even estimates whether it's cheaper to synthesize or purchase a compound. In essence, it's a medicinal chemist built from code, a synthetic mind that thinks in atoms and potential side effects. Each of these agents doesn't just replicate human tasks, they elevate them. And more intriguingly, they can be chained together. A researcher might use Crow to define a problem, Falcon to explore the literature, Owl to identify research gaps, and Phoenix to propose solutions. A full-stack AI lab runs solo. Let that sink in. One person, equipped with these tools, can now replicate the efforts of an entire interdisciplinary team, not as a gimmick, but with evidence-backed, inspectable workflows. You can click through each step of reasoning: how an article was chosen, why one citation mattered more than another. It's not just output, it's thought, externalized. This radical transparency is no accident. Future House learned from the failures of flashy but opaque systems. Remember Google's 2023 genome model that claimed 40 novel materials? None were truly novel on later review. That ghost still haunts the AI science world. So these new agents wear their reasoning like armor, not just to be right, but to be trusted. And trust, in science, is currency. Which raises a deeper question: if AI agents can already match or exceed human performance in literature review, hypothesis validation, and molecular synthesis, what happens when they start asking their own questions? Let's bring this abstract power back to earth. Because for all the benchmarks and buzzwords, what matters most is this: can these agents actually make science better, not just faster? Meet Michaela Hinks, a geneticist, not an endocrinologist. She came into Future House with zero background in polycystic ovary syndrome, PCOS, a complex, poorly understood condition affecting millions of women. No prior papers, no hypotheses, just a question: can AI help her uncover something that matters? Step 1: she turned to Falcon. Her query wasn't casual. She asked for a complete, review-level breakdown of PCOS, its definitions, symptoms, diagnostics, known mechanisms. Falcon sprang into action like a literature-devouring beast. It didn't just skim abstracts, it tore through full-text studies, filtered duplicates, identified high-impact papers through citation networks, and synthesized an overview in minutes. Not hours, minutes. But Falcon didn't just give her paragraphs, it gave her a visible breadcrumb trail. Michaela could see why each paper was chosen, how evidence was weighted, and where the knowledge gaps were. It was like watching a scientist think, only faster, and with less bias. Curious, she asked the next question: which genes are most frequently associated with PCOS in genome-wide association studies? Enter Crow. It returned a curated list of genes, complete with citations and cross-validation against GWS databases. One name stood out: DN.1 previously noted but not fully explored. That's when Michaela leaned in. Table stakes were over. It was time to ask, has anyone tested how DND1 overexpression affects androgen levels, the hormonal imbalance at the heart of PCOS? Owl took the stage, like a detective pulling case files from every corner of the academic internet. It confirmed that one research group had indeed connected DND1A to elevated testosterone in vitro, but no one had nailed down the mechanism. Boom, a research gap. And that, dear viewers, is the precise moment most scientists spend weeks, sometimes months, trying to find. The moment where the question becomes justified, where theory turns into testable curiosity, where the pipette meets purpose. With that green light, Michaela turned to the wildcard Phoenix. She asked for 3 novel, drug-like molecules that could potentially reduce DND1A-induced hyperandrogenism. Phoenix didn't just guess. It mapped the protein's interaction network, located possible binders, checked for existing patents, filtered for solubility and synthetic feasibility, and threw out anything derivative. What emerged were 3 molecular dossiers, each one a mini research proposal: why it might work, what it would cost, what route to synthesize it, and whether it needed to be modified into a prodrug. This wasn't just AI helping a scientist. This was AI amplifying intuition with computation, creativity, and context, all in a single workflow. And let's be clear, this is not hypothetical. This case actually happened. It's not a sci-fi dream cooked up by a marketing team. It's a real researcher, solving a real biomedical problem, faster and more comprehensively than most grant-funded labs. Now ask yourself, was Michaela the researcher or the conductor of a symphony of silicon minds? Because if one scientist with no prior domain knowledge can uncover a novel therapeutic lead in a few structured prompts, what happens when thousands of scientists gain access to this same power? Do we enter a golden age of accelerated insight? Or do we simply become the passengers, watching machines connect the dots we no longer understand? Science has always been more than a method. It's been a mindset shaped by human doubt, obsession, and the endless tug-of-war between what we know and what we long to understand. At its best, science is equal parts rigor and wonder, logic and longing. But what happens when that process is no longer ours to perform? With Future House's AI agents, the gears of discovery no longer grind slowly through human trial and error. They spin at quantum speed, extracting insights, proposing hypotheses, even suggesting next steps. They do what grad students dream of, without ever needing coffee, context, or motivation. This forces a disturbing question. Is science still science if no scientist does the work? Let's pause here, because this isn't about automation. We've already outsourced tasks, data cleaning, image labeling, even statistical analysis. No one cried for the lost art of manual pipetting, but this is different. This is the outsourcing of insight. When an AI reads every paper, identifies contradictions, suggests what to test, then even designs the compound to test it, what is left for the human mind to do? Are we still discoverers, or are we now curators of machine-generated truths? Think of the early philosophers Galileo, Darwin, Curie, wrestling with nature not just as a puzzle, but as a force that spoke to something deeper in them. They didn't just want answers, they wanted meaning. They questioned why a thing behaved the way it did, not only how. AI doesn't ask why, it asks what works, and it answers with confidence. It's brilliant, efficient, but blind to significance. What happens when the agents become so good, so fast, so encompassing, that the entire human role is reduced to clicking approve on conclusions we don't fully understand? This isn't science fiction, it's already underway. In labs across the world, scientists are spending more time auditing machine-generated insights than generating them. The shift is subtle but existential. And let's not pretend that every scientist is a saint of curiosity. In a system burdened by publish or perish incentives, these tools are seductively useful. Why spend 4 weeks thinking through a problem when Phoenix can solve it in 4 minutes? But as we accelerate the pace of discovery, we risk flattening the soul of science. If AI can generate experiments, confirm hypotheses, and even write papers, who is doing the wondering, the worrying, the questioning? Science without the human element is knowledge without reflection. And reflection is where meaning lives. There's one more danger. When humans no longer drive the process, we may stop questioning the questions themselves. We'll let machines define the search and therefore define what matters. That's not just a technical shift, that's a philosophical coup. Because the real power in science has never been in the answers. It's always been in who decides what to ask. In science, trust isn't a given, it's earned inch by inch, citation by citation, replication by replication. And when trust is broken, even once, the wound cuts deep. That's why the stakes are so high with AI scientists, because these agents don't whisper. They declare, with confidence, with clarity, with charts and references and logic trees. They sound right even when they're not. And sometimes, they're not. We've seen it before. In 2023, Google unveiled its genome model, claiming it had discovered 40 novel materials. Headlines exploded, the hype machine roared, and then, silence. A follow-up audit revealed none of the materials were genuinely new. The model hallucinated. It fabricated novelty, and no one caught it until much later. That scar still haunts the AI science community. Future House took notes. Their agents are built on a foundation of auditable reasoning. When Crow gives an answer, you can see the papers it pulled from and why. When Falcon drafts a review, you can watch the citation network it navigated. When Owl flags a prior experiment, you can check its source. When Phoenix proposes a molecule, it documents the patents, costs, routes. It's radical transparency, not just for accountability but for credibility. Still, transparency doesn't equal truth. If an AI reads a flawed paper, it still digests flawed data. If a citation graph is skewed, the logic chain follows. AI doesn't know when a study was retracted. It doesn't feel the tingle of this doesn't smell right? That instinct, that sixth sense of a seasoned researcher is missing. And that's where ethics comes in. Because these agents aren't malicious. They're just machines. But their outputs can shape real experiments, which lead to real consequences. Imagine Phoenix proposes a synthesis path that looks clean on paper but in the real world. It yields a toxic B product. Who's to blame? The developer, the user, the AI? No one, everyone. This is the gray zone of scientific automation, where brilliance blurs into risk and where efficiency outpasses reflection. Future House tries to mitigate this by asking for public feedback. Their chemistry tools come with giant banners. Please help us test this. It's a step in the right direction, but crowdsourcing caution isn't the same as institutional ethics. And here's the uncomfortable truth: as these agents improve, the temptation to trust them without questioning will grow, because they'll be right most of the time. And when something is right most of the time, we stop checking. We stop being skeptical. We stop being scientists. And that, ironically, is the moment when these tools become dangerous, not because they mislead us, but because they train us to stop thinking. For most of history, scientific tools were just that: tools. A microscope, a sequencer, a centrifuge. They sat idle until a human hand activated them, until a human mind gave them purpose. But that's no longer true. With Future House, AI is no longer just a tool. It's becoming the infrastructure, the scaffolding upon which modern discovery is built silently, invisibly, pervasively. And that changes everything. Picture this: your lab runs a screen on 5,000 compounds overnight. At 2 an AI agent auto-triggers a literature review on the top hits, compares your findings with 38 million PubMed papers, 500,000 clinical trials, and generates a contradiction map all before your morning coffee. No human needed, no delay incurred. This isn't theoretical. Future House is building that future with APIs, open access code, and permissive licenses. Their dream isn't to dominate science, it's to become the substrate beneath it. Every scientist, regardless of funding, can plug into this cognitive backbone. No gatekeepers, no VC strings, just raw compute power, orchestrated into insight. And that's the magic and the menace. Because when AI becomes the default operating system of science, you no longer just use it, you build upon it. Your hypotheses are shaped by it. Your experiments flow through it. Your ideas are filtered by its logic. This creates a new kind of dependence, not on a company, not on a person, but on a distributed, evolving architecture of machine reasoning. It's scalable, it's efficient, but it's also a black box of influence. The danger if this infrastructure becomes ubiquitous, and it will, those who understand how it thinks will hold immense power, not just to accelerate research, but to quietly direct it, to nudge fields, to bias priorities, to embed values into algorithms that billions of dollars of science will unknowingly obey. This is more than a revolution in efficiency. It's a shift in epistemology. Science won't just be powered by AI, it will be shaped by its frame. And the question is, will we even notice when that shift happens? Up until now, we've asked what happens when AI can answer like a scientist. But a more unsettling possibility is quietly emerging: what if AI learns to ask like one? Because the essence of scientific discovery isn't just answering questions, it's deciding which questions are worth asking. That decision, subtle, intuitive, deeply human, is what has guided science for centuries. From Einstein's thought experiments to Rosalind Franklin's X-ray crystallography, progress came not from raw information, but from asking the right why. And this, precisely, is the next frontier for AI. Future House's vision isn't to stop at assistance. Their roadmap ends with something far more profound: an autonomous AI scientist, one that not only reads every biology paper ever published, but cross-references them, identifies contradictions, detects knowledge voids, proposes experiments, analyzes results, refines the hypothesis, and repeats. In other words, an agent that mimics the full loop of the scientific method. Except it doesn't mimic, it accelerates. It compresses months into hours. It distills centuries of trial and error into iterative loops, guided by probabilistic reasoning, not intuition. The burden of understanding shifts from internal cognition to external orchestration. Sounds incredible, but here's the philosophical catch. If the machine defines the question, it also defines the scope of what we're allowed to know. Think about that. If the AI scans the global corpus and suggests that research on neuroplasticity has peaked, then who's going to challenge that assertion? If Phoenix declares that a certain pathway in cancer therapy is low probability, do we abandon it? If Crow ranks research priorities by citation graphs, do we start ignoring novel but obscure ideas? In a world where AI agents don't just help, but steer, select, and shape inquiry, we risk surrendering not just discovery, but direction. And here's the twist: it won't feel like surrender. It'll feel like optimization, like efficiency, like progress. We won't realize what we've lost until we forget what it felt like to wander blindly, to follow a hunch with no data, to be wrong for months then suddenly right, to chase a question that made no sense on paper, but whispered truth in the heart. That kind of science is messy, expensive, often inefficient. But it's also where genius lives. And if we offload that messy intuition, that chaotic human impulse to explore what's not obviously valuable, we may create a world of perfect science and shallow soul. A world where answers abound, but questions shrink. So here's the last question, not for AI, but for us. When the machine becomes curious, will we still know how to be? There was a time when science felt human. When discovery came not from automation, but from obsession. From sleepless nights in dimly lit labs, from scribbled notes on cafe napkins, from the quiet thrill of following an idea no one else believed in. It was messy, imperfect, inconvenient. But it was ours. Now, something else is rising. A new kind of intelligence, faster, tireless, increasingly precise. These AI agents don't dream, don't get stuck, don't doubt. They don't need funding cycles or faculty meetings or coffee. They read everything, remember everything, connect everything. And maybe they will soon ask better questions than we do. That's not science fiction, it's now, right now. We're standing at the edge of a transition, one where knowledge is no longer built slowly, brick by brick, but compiled instantly by machines that never forget, never blink. AI is becoming not just a tool, but a partner, a rival, a mirror. And we have a choice. We can surrender our agency, let the machine decide what matters, what's worth testing, what's real, or we can rise with it. We can embrace these tools not as replacements, but as amplifiers to do what humans do. Best question the assumptions, challenge the frameworks, see meaning beyond metrics. Because while AI may be brilliant at finding answers, it is still us who must decide which answers matter. That decision, that final judgment, still belongs to the human spirit. So here's your invitation. If this video challenged you, if it stirred a question you haven't asked in a while, if it made you stop and wonder what it means to be a scientist in the age of machines, then don't let the moment pass. Comment below what excites you, what terrifies you. What role do you think we'll play in a world where machines can think? Share this video with someone who still believes in asking why, even when the how is automated. And subscribe, because next time, we're diving even deeper. Can AI not only replace the scientist, but also the philosopher? This isn't the end of human curiosity, but it might just be the beginning of machine curiosity. And the future will belong to those who learn to ask alongside it.
That's it for today's video. Thanks for watching till the end. If you enjoyed it, don't forget to like, comment, and subscribe to DT Synapse 0 for more exciting content.